The definition of a periodic function, lesson 4.2, and this is in your book. A function is periodic if there exists a positive number p such that f of t plus p equals f of t for all t in the domain of f. The smallest positive number p for which f is periodic is called the period of f. So basically what that means with our unit circle here is that if we pick a point on the circle, let's say right here, and let's say this is after a 45-degree turn, we found from the previous page that the cosine of 45 is radical 2 over 2. The sine of 45 degrees is radical 2 over 2. So this is a 45-degree turn. So what this means is if I turn 45 degrees, but then if I also turn another 360 degrees, I'm still going to end up at the same spot. So 45 degrees plus another full turn, 360 degrees, is going to be 405 degrees. So the cosine of 405 degrees is going to be the same. So we say the period of this function is 360 degrees, or 2 pi, because when it goes that distance around the circle, you end up at the same spot. Okay, and so that's what I'm trying to say here. The sine of t plus 2 pi is the same as 360 degrees, it's just in radians, is the same as the sine of t. And the cosine of t plus 2 pi is the same as the cosine of t, because this is just one revolution extra. All right, now periodic properties for tangents and cotangents. The tangent is going to be the same after just 180 degrees, or pi. The cotangent is going to be the same after pi. So the period of the cotangent function is pi, the period of the tangent function is pi. So what this means, let's look at our 45 degrees again. The tangent is the sine divided by the cosine, so that would be 1. So the tangent of a 45-degree turn is 1. So if I turn 180 more degrees, which is pi, I end up down here. And the coordinates down here are negative radical 2 over 2, negative radical 2 over 2. But it's still, the tangent would be negative radical 2 over 2 divided by negative radical 2 over 2, which would be 1. And remember what I said about tangent being the slope of a line. This line has a slope of 1. If you're up here, it has a slope of 1. If you're here, it has a slope of 1. So the tangent of 45 is the same as the tangent of 45 plus another 180 degrees, or pi over 4 plus another pi. All right, so find the value of each trigonometric function. If I want the cotangent of 5 pi over 4, the first thing I did is I changed 5 pi over 4 into degrees by multiplying by 180 degrees over pi to get 225. 225 lands me down here, okay, 225 degrees. That's 180 plus 45 more is 225. It's going to be the same here as it would be up here. So it's the same as the cotangent of pi over 4, which we found on the previous page. The previous page, cotangent of pi over 4 is 1. The cosine of negative 9 pi over 4, well, here's pi over 4. That's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, negative 9 pi over 4. Okay, I wasn't saying the negatives, but I was turning clockwise, which implies negatives. So negative 9 pi over 4 lands me at the same place as negative pi over 4. And because cosine is an even function, these two things will be the same, so it's radical 2 over 2, which we got that answer on the previous page. The cosine of 9 pi over 2, you can change it into degrees if you want, or you can just count 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. 9 pi over 2 is the same as pi over 2. In other words, 90 degrees. I just kept counting by blocks of pi over 2 or 90. So pi over 2, the sign would be 1 because the sign is the y coordinate. Using a calculator to find the value to 4 decimal places, the cosecant of 1.5 is 1.0025. Now, if you have a graphing calculator, you're going to need to go into mode, which is next to the second button. And do you see how there are two options, radian or degree? Right now I'm in degrees. I'm going to have to use my arrows, and I'm going to go to radians, and I'm going to arrow over this way, and I'm going to hit enter down at the bottom. And now I'm in radians. So now I can quit out of there. And then how I'm going to do cosecant is I know it's 1 divided by the sine. So you're going to do 1 divided by, open parentheses, sine of 1.5, close parentheses. Then I have to close them again because there were 2 parentheses opened, and then hit enter. Now you might say, how did I know I was in radians? Well, if I don't put a degree up here, then you're in radians. If you don't have a graphing calculator, if you have one of these other calculators, the button's up here, DRG. Right now it's in degrees. You're going to want to switch it. When you press that, you're going to want to arrow over to radians, and you use that. And so make sure it's on. Now we know once we hit enter, now it's switched to radians, and we'll do the same thing, follow the same key sequence. If we have the sine of pi over 4, we already know my mode's in radians, and that pi over 4 is in radians. So I just have to do sine, and then I can use the pi button, which is yellow here. So I have to do second that divided by 4. Okay, the sine of pi over 4. So only do that if they ask you specifically to use a calculator. Otherwise, do it out by hand.